So there are three conditions you have to look for to satisfy this condition. The first one is any number to the power of 0 is 1. The next one is 1 to the power of anything. That would also be 1. And the one that almost everyone forgets is minus 1 to some even integer would also be 1. So you have to consider all three cases. So the first thing we'll start with here is to make the exponent 0, which would happen when x is minus 1. And if you want to be careful, you can compute this out. This would be 1 plus 5 plus 7, which would be 13. And 13 to the 0 is indeed 1. So our one solution is minus 1. Next case is when what's inside is equal to 1. So we can equate this to 1, which then becomes this quadratic. And this can be easily factored to x minus 2, x minus 3 equal to 0. So the two values for x are 2 and 3. And this would, of course, be 1. And the exponents here would be 1 to the 3 and 1 to the 4, which are, of course, both equal to 1. Sometimes I always will plug it back in to just absolutely make sure that I'm not making a mistake. So these are my two additional solutions. And then finally, we have to look for when what's inside the base here is minus 1. So this becomes x squared minus 5x plus 8 equals to 0. Now the question is what values of x would make this. So first thing I'll do is I'll examine the discriminant and see what the roots are. So this would be 5 squared minus 4 times 1 times 8. And that's 25 minus 32, which is minus 7 negative. That means there are no real roots. So this will have no real solution, so we will not be getting any of these situations. So the answer is these three solutions, which is choice A.